In this video, we'll import a tooling library and we'll use prime turning to create a facing and rough toolpath. I have prepared a tooling library as part of your downloads in this class to support processing this part. Let's import that library into our project now. In the Turning tab, I'm going to go to the Lathe Tool Manager. In our current project, we should see one tool, T0101. This is the tool that we selected during job setup. I'm going to browse to where I have the tool library. You can browse to wherever you've put your tool library. These are the tools we will use to process our part. Notice the numbering of the tools in the library. Our drill is T0101. Our left-hand turning tool is T0101. Our drill facing to the right spindle is T0202. I'm going to grab all these tools and drag them up. And you'll notice that they have now been renumbered. This is because I have assigned tool numbers sequentially selected in the tool settings. I believe this is on by default. When working with libraries of your own, you might want to turn this setting off. Let's start to create some tool paths. I have created level 30 and 130 for the geometry created by the tool paths we will be creating. I've made level 30 active. I'm going to turn off the solid model and turn on the turn profile. I like what I see right here. I could adjust the screen if I wanted to, but I'm going to go ahead and save this view sheet bookmark so we can return to here easily. I'm going to go up to the facing toolpath and turning. First thing we want to do is go to the proper axis combination. In this case, this will be upper left. We have a few options here, but of course we want the turning upper left. It's good workflow to incorporate the axis combo first into the toolpath. The axis combo pairs a spindle and a turret. It will also filter lathe tools in the library available for use with that particular axis combo. I'll go back and select the tool. We're going to use the A-style prime turning insert for both the facing and the rough operation. I'm not going to change speeds and feeds. I'm going to work with whatever defaults we have. I'm concerned with the tool paths and the process itself. I'll go to the face parameters and I'm going to change the overcut amount to get past center just a little bit. And I'm going to use the cross center line cut. This is the most efficient way to use the prime turning tool for facing when we can get across the center line. So we have a tool path created. I'll go to the toolpath manager and I'll backplot this. Looks good, and you can see that we are using a 3D tool here. I'll say OK to this, and I want to take a look at this new tool. So I'll double click on the insert and you can see that it opens up the tool and it opens up the tool designer. 3D tooling is new in Mastercam 2019. You can see the different components to the tool designer. To learn more about 3D tooling, please contact your reseller. There is also additional material on Mastercam University, which currently includes a webinar that details how to use 3D tooling. All customers who are active on maintenance can access our webinars. I'll be using a combination of conventional parametric tooling as well as some of the new 3D tooling in this project. I'm going to return to my view sheet left, and then I'll go up and select the prime turning toolpath. Prime turning toolpaths were introduced in Mastercam 2018, and they are a little different than conventional toolpaths. I'm going to use a prime turning toolpath to rough the material on this part. And we'll start by picking out the chain, starting here and going down to the chamfer on the front. We have three different tabs, a rough, a finish, and the toolpath parameter tab. So the first thing we want to do is select our axis combo, and we want turning upper left. We have our tools selected. And in rough, we'll come back to that in just a second. And we don't want to finish. So I'm just going to turn off the finish part of this toolpath and come back into the rough parameters. So we can see that we are going to rough it. The strategy we're going to pick is horizontal. We'll take a depth of cut of 2 with a minimum depth of cut of 0.5. And I want to take a look at the stock that it sees. So this is what I would expect. Prime turning uses stock to calculate the toolpath. So checking to see what it sees for stock is always a good idea. If for some reason you don't see something similar to this, you can adjust your stock using these controls here. So I'm going to go ahead and green check out and see what we get. So we have a nice looking toolpath here. That's good for now. I'm going to go ahead and backplot this toolpath. You probably noticed I chained in an opposite direction from a normal turning toolpath. This is the motion that is most efficient for prime turning tools. Due to the design of the insert, it allows them to run at significantly higher speeds and beads than conventional toolpaths, and usually gives better chip control as the motion is away from the spindle. I've just scratched the surface here with prime turning toolpaths. To learn more about them, please talk to your local Mastercam reseller or Sandvik rep. Also, look at our prime turning course on Mastercam